Today, we're going to be jumping into something pretty fascinating. We're talking about algorithmic architecture, like where computer algorithms and architectural design kind of, well, they collide.
Yeah.
And, you all shared some sources with us that really got us thinking about, how computers are being used in architecture, everything from like generating forms to like, those big like philosophical questions about, creativity and control.
Right.
So, today we're going to really try to distill all that down, kind of synthesize the core ideas for you.
Absolutely. Yeah. I mean, the sources that you provided offer a really great overview, and we're going to try and synthesize the most crucial ideas for you, sort of unpack them. And I think our main lens that we're going to be looking through today is Kostas Terzidis' book, Algorithmic Architecture. And we'll be looking at kind of the historical context of that, looking at some of the techniques that he discusses, like scripting and shape grammars, and also looking at kind of the broader implications of, what this all means.
Yeah.
And our goal really is for you to really understand how algorithms are shaping, the buildings and the cities around us, and even how we think about the act of designing.
Okay, so this book starts with a question that feels, surprisingly relevant even now, which is what exactly is the computer's role in architectural design? It sounds like this was like a big question back in the 50s and 60s, and it kind of popped up again with the rise of advanced computer graphics. Why is this still like such a key debate, do you think?
Well, it is kind of fascinating that despite all of the advancements that we've seen in technology and in computation, architecture,
Yeah.
That this question of this sort of fundamental question about the role of computers in design is something that hasn't really been resolved, and it really kind of highlights that there is this sort of ongoing discussion or debate about the relationship between human creativity and computational power.
Right.
Are computers simply tools to execute our designs, or are they becoming more integral to the very process of of conceiving those designs?
Yeah.
And I think the fact that this question kind of resurfaced, with the rise of advanced computer graphics, I think suggests that while the visual possibilities kind of exploded,
Yeah.
The fundamental way in which algorithms were sort of influencing design thinking still needed kind of more careful consideration, I think.
And Terzidis even goes into like the nature of algorithms themselves.
Right.
And he even kind of draws these parallels to how our own minds work. And he suggests that we also follow rules when we're being creative.
Right.
To avoid just repeating ourselves.
Right.
So is this otherness we sometimes like ascribe to machines, is it actually mirroring something within our own like creative process, this interplay between freedom and constraint?
That's a really insightful way to put it. Yeah. I mean, if you think about it, if our own minds are operating with kind of internal rules and patterns when we're generating new ideas,
Yeah.
then the line between human thought and algorithmic procedures kind of becomes a bit more blurred, I think.
Yeah.
You think about how a musician follows scales and chords, or how a writer adheres to grammatical structures.
Right.
And I think this kind of old idea from Diderot, who talked about the predictability of the mind in relation to machines, I think still resonates here.
Yeah.
It kind of challenges this purely romantic view of human creativity as being completely free, and suggests that maybe there's a more structured foundation there,
Yeah.
both in humans and in computational design.
It makes you think differently about like where new ideas actually come from.
Right.
And then the book talks about, design and innovation, and it brings up this Greek word, seidon, linking design to like a past loss.
Right.
Which is so different from the Western obsession with constant novelty.
Right.
And even the definition of innovation having this as if for the first time aspect.
Wow.
It makes you wonder if true novelty is even possible.
Yeah. I mean, I think what's so intriguing there is this kind of cultural difference in how design is perceived.
Right. Right.
So you have this kind of Greek idea with its connection to something lost, which implies a process of kind of revisiting, perhaps restoring which is quite unlike the kind of Western emphasis on always creating something brand new.
Right.
And that, as if for the first time, part of innovation, I think, points to a very subtle distinction.
Yeah.
Which is, is it about genuine originality, or is it about the appearance of being new?
Right.
And I think the book suggests that true innovation, lies in being productive and having an influence,
Right.
not just in being different for the sake of it.
Yeah. Yeah.
And novelty, I think, can sometimes be a very superficial layer.
Right.
So for you, thinking about your own creative endeavors, does this idea of cadence and this pressure to be constantly new, does that resonate?
Yeah.
And does it perhaps make you, consider the value in reinterpreting and building upon what already exists?
It's like we're always striving for something that might not even be attainable in the way we think.
Right.
And then this idea of existence gets a similar treatment. Looking at the English root, meaning like appearance versus the Greek root, pointing to something beyond the beginning.
Right.
It suggests a deeper context than just like a starting point.
Yeah.
And becoming is about transformation, not just creation.
Right.
Which challenges this idea of design as simply adding elements together.
Yeah. I mean, if we connect this to sort of to a broader understanding of things, the etymology of existence kind of hints that things have underlying frameworks or conditions that precede their initial appearance and becoming, then isn't necessarily about something popping into existence out of nowhere,
Right.
but more about a shift or an evolution from one state to another.
Yeah.
And this actually aligns with some very, very old philosophical ideas, that rejected the notion of something suddenly appearing or disappearing.
Right.
So for you, this might suggest that when you're designing, you're not always starting from a blank slate, but rather transforming, existing conditions or ideas.
This is shifting my perspective on so many things.
Yeah.
Then we get into memory and feedback, and the book uses the flip-flop circuit as this basic way of remembering a previous state. How does this apply to like the complexities of architectural design?
Well, what's key here, I think, is this concept of feedback loops as being fundamental to how systems, whether electronic or design oriented, remember and evolve, right?
Yeah.
So the flip-flop circuit, in its simplest form, demonstrates how a system can retain information about its prior state. And in architectural design, think about how you might iterate on a design based on simulations or client feedback.
Right.
And so each iteration kind of builds upon the previous one. It's remembering what worked, what didn't.
Right.
That kind of guides the design process, right?
Right.
Imagine you're designing a building's energy system, and you get feedback on its performance during different times of the year.
Right.
That feedback loop informing your next design adjustments
Right.
is a more complex version of the flip-flop's basic principle of retaining information to influence the next state.
Right. And then there's this section on the impossible. It sounds like what we consider impossible is constantly being redefined by technology. The example of memorizing pi, versus supercomputer calculations really highlights that.
Right.
And the book even suggests that, like, theoretically, with enough time and resources, nothing might be impossible, which is kind of a crazy thought.
Yeah, it raises a really interesting point about the ever-shifting boundaries of what we perceive as achievable.
Yeah.
Especially in a field as technologically driven as architecture is becoming. What seemed like a fantastical idea, just a few decades ago, might be commonplace now.
Yeah.
We think about the advancements in material science or in digital fabrication.
Right.
So this theoretical idea that infinite resources could unlock any possibility really pushes you to think beyond, kind of current limitations.
Yep.
What impossible architectural challenges, do you think might become feasible in the coming years? And how might that change how we approach design.
This leads into meta-algorithmics, algorithms that can generate other algorithms. That sounds pretty abstract.
Yeah.
And it brings up this fascinating question of intellectual ownership, you know?
Right.
If an algorithm creates something truly unexpected, who owns it? The programmer,
Yeah.
the user, or even the algorithm itself in some like theoretical sense.
Well, what's so intriguing here is how it kind of challenges uh, our traditional human-centric ideas about authorship and control.
Right.
If an algorithm produces, a novel design solution that wasn't explicitly envisioned by the programmer,
Yeah.
The link between the creator's intent and the final outcome,
Yeah.
becomes less direct.
Right.
And this really makes you consider, if an AI generates a truly innovative architectural form, who should be credited?
Yeah.
And on a more practical level, how might this impact, copyright and intellectual property laws, in the future of design?
Yeah.
I think the introduction of this idea of a theoretical otherness as a potential owner is a really thought-provoking way to kind of push the boundaries of our understanding of creative agency.
It's like the tool is starting to have its own kind of like creative agency.
Right.
And this unpredictability kind of extends to the idea of computers as tools in general.
Right.
They can surprise us with unexpected results.
Right.
Which challenges the traditional notion of a tool being like entirely under our control.
Right.
So does this mean that intention isn't always like a necessary component of design, or is it not exclusively a human attribute anymore?
I mean, this really gets to the heart of this the kind of evolving relationship between designers and their computational tools.
Yeah.
The inherent unpredictability in algorithmic processes,
Yeah.
I think suggests that computers can be more than just passive instruments.
Right.
They can become active participants in the design process,
Yeah.
leading to outcomes that might go beyond, the initial intentions of the designer.
Right.
And so this really forces us to reconsider the role of intention itself.
Yeah.
Is it the sole driving force behind design, or can unexpected, algorithmically generated result
Right.
also be considered, valid and valuable contributions?
Yeah.
Yeah. Okay. So then the book talks about like these two main perspectives on intellectual activity.
Mm.
The human mind as uniquely creative versus acknowledging like the superior processing power of computers.
Right.
It sounds like humanistic approaches really value self-determination and control, while the potential for unpredictability might point towards a non-human element at play.
Yeah, I think what's important to grasp here is this fundamental divergence in how we understand intelligence and creativity, right?
Mhm.
So the humanistic view really places emphasis on subjective experience, on consciousness and intentionality
Yeah.
as the defining characteristics of intellectual activity.
Yep.
On the other hand, the computational perspective really recognizes the immense processing capabilities of computers,
Right.
and suggests that intelligence and even creativity can emerge from complex algorithms.
Yeah. Potentially exceeding human, limitations in certain areas.
Right.
And so I think unpredictability in this context can be interpreted as a manifestation of this non-human, computational intelligence at work.
Right.
Yeah.
And this kind of brings us back to intellectual property in algorithmic design. It seems like while designers typically hold the rights to their work, these algorithmic forms with their inherent randomness, like introduce a layer of complexity.
Right.
The output might extend beyond the designer's direct control, kind of hinting at an intellectual origin that's not solely human.
Right.
This idea of a synergy between human and machine creativity becomes really crucial.
That's a key insight, I think. The potential for algorithms to generate unexpected and complex outcomes, challenges kind of traditional intellectual property frameworks.
Yeah.
That are primarily based on human authorship and control. And so the resulting designs can exhibit, a level of complexity and novelty that seems to have an intellectual root beyond the designer's, direct manipulation.
Yeah.
And this really highlights, I think, the growing importance of understanding, this collaborative relationship between human intention
Yeah.
and the expansive possibilities offered by computational processes.
Okay. So the book also makes a clear distinction that design at the information processing level in computers isn't inherently neural,
Right,
even though we often draw like analogies between brains and computers.
right, right.
Computers operate through mathematical and logical procedures,
Mhm.
which are fundamentally different from the abstract and intuitive nature of human thought.
Precisely, yeah. I mean, while the analogies between the human brain and computers can be useful for understanding certain concepts,
Yeah.
it's crucial to remember that the underlying mechanisms are quite distinct.
Right.
So computers process information through defined mathematical and logical steps,
Yeah.
whereas human thinking involves a much more complex interplay of emotions, intuition, and consciousness that we don't yet fully understand in computational terms.
Then we delve into the concepts of possibility and randomness. It's interesting to realize that even like seemingly impossible outcomes have a statistical probability,
Right.
however small.
Mm.
And genetic algorithms use this idea of fitness
Yeah.
to make the search for possibilities much more efficient.
Right.
It seems randomness isn't just chaos, but something that can be explored and harnessed within certain limits of time and resources.
Yeah, I mean, what's fascinating there is realizing that randomness isn't necessarily the opposite of order.
Right.
Even highly improbable events, have a chance of occurring. Right, and genetic algorithms, I think, demonstrate how introducing a mechanism of selection based on a defined fitness criteria
Right.
can guide a random search process towards desired outcomes much more effectively than simply trying every possibility.
Yeah.
And so this shows how randomness can actually be a really powerful tool, for exploration within computational design.
Right.
And information in this context, I think, becomes this active process of filtering through that randomness
Yeah.
to find order and meaning.
And the if then else clause in programming is brought up. Apparently that simile else can lead to unexpected outcomes, unlike the more straightforward if then.
Right, right.
It's a small detail that highlights how algorithms can like surprise us.
Yeah, I mean, it's a really crucial aspect of algorithmic logic that can lead to these emergent behaviors.
Yeah. So the else clause, introduces a branching path, allowing the program to deviate from a purely linear sequence of instructions.
Right.
And so this is often where unexpected and potentially innovative results can arise.
Yeah.
And showcasing this capacity of algorithms to generate outcomes that weren't explicitly foreseen in the initial if-then statement.
Okay, so some designers apparently find the fixed logic in algorithms too restrictive, preferring the intuitive act of composition.
Mm-hmm.
But the book argues that this resistance might prevent us from fully, exploring the potential of rationalization in design.
Yeah, this points to a kind of long-standing discussion in the field. This balance between intuition and logic in the creative process. So
Right.
while some designers prioritize the subjective and experiential aspects of design,
Right.
potentially viewing the structure nature of algorithms as limiting.
Yeah. The book suggests that embracing this rational, computational approach
Yeah.
can actually unlock new possibilities and push the boundaries of what's achievable in design.
Okay, so now we get into the early history of what the book calls algotecture.
Mm.
It sounds like early CAD systems tried to automate design based on existing architectural rules,
Right.
but they often missed the crucial connection between a building and its surrounding environment, and still required a lot of manual input from the designer.
That's right. Yeah. I mean, the initial aspirations for CAD were often centered around automating, traditional, drawing and design processes based on established architectural knowledge.
Right.
However, these early systems often struggle to capture, the complex and dynamic relationships between a building and its context.
Right.
And the designer really remained largely in control of guiding the design's evolution.
Then the discussion kind of moves to form-based design and shape grammars,
Mm,
which use specific rules to generate designs visually,
right.
kind of offering a sense of rationality and consistency.
Hmm.
Fractal systems kind of take this further by recursively repeating shapes, creating
Hmm.
these incredibly complex forms,
Right.
although they often need functional constraints to be useful in architecture.
Yeah, so shape grammars, I think, represent a significant step towards formalizing design logic.
Right.
They use these visual rules to create consistent and predictable forms.
Right.
Fractal systems, then demonstrate the power of repetition and scaling to generate intricate complexity from simple initial rules.
Yeah.
However, as you pointed out, the challenge in an architectural application often lies in ensuring that these purely form-driven systems also address functional requirements and real-world constraints.
Okay, so the book also touches on computational strategies,
Mhm.
and the idea that a systematic, logical approach can be really effective for solving design problems. However, it also reminds us that design is often inherently ambiguous,
Right.
and that ambiguity can sometimes be the source of really creative solutions, as seen in Frank Gehry's more metaphorical design process.
Right.
It highlights that not everything in design can be easily described in literal verbal terms,
Right.
especially when we're exploring new ideas.
This underscores, I think, the inherent tension between the desire for rationalized, systematic, design processes,
Yeah,
and the often intuitive and ambiguous nature of creative problem solving.
right.
So while computational strategies offer these powerful tools for exploring design possibilities in a structured way,
Right.
um, the metaphorical and nonverbal aspects of design highlight the limitations of purely logical approaches
Yeah.
in capturing uh, the full spectrum of creative thought and the emergence of truly novel concepts.
Right.
Think about how difficult it can be to fully explain um, the feeling or the atmosphere you're trying to create in a space.
Yeah.
And sometimes those nonverbal cues and ambiguities
Mm.
are essential to the design process.
Okay, and then there's this interesting point about the separation between the people who create the computational tools,
Mm.
the programmers and scientists and the architects who use them.
Right.
This can sometimes lead to a gap in understanding the underlying mechanisms, like the philosophical idea of smoothness versus the actual mathematics of N or BS curves.
Yeah, this highlights a critical challenge, I think, in the field of computational architecture,
Yeah.
which is the potential disconnect between uh, the developers of the tools and the designers who use them. So a lack of shared understanding about the fundamental principles and limitations of these tools can really hinder their effective and innovative application.
Right.
Um, and the example of Deleuze's philosophical concept of smoothness, not perfectly aligning with the mathematical definition of NURBS curves,
Yeah.
illustrates how different perspectives and levels of technical understanding can lead to misunderstandings or underutilization of the technology.
Okay, so the book then clarifies like what an algorithm like actually is.
Right.
While we often think of it as like a fixed set of steps with a clear end, algorithms can sometimes lead to infinite loops
Right.
or unpredictable behavior, like when they involve random number generation.
Yeah.
So it's not always as simple as we might think.
That's an important distinction. Yeah, I mean, while the basic definition of an algorithm involves a finite sequence of instructions,
Yeah.
the execution of those instructions can in certain cases lead to outcomes that are not necessarily finite
Right.
or entirely predictable.
Yeah.
And so this inherent potential for non-deterministic behavior is
Yeah.
it's a key characteristic of some algorithmic processes
Yeah.
and contributes to their capacity to generate novel and unexpected results in design.
So now we get into the practical side. with an introduction to scripting using MLL in Maya.
Okay.
And it covers the real basics like variables, different types of data, arithmetic and logical operations, arrays,
Right.
and how to work with geometric objects and transformations like moving, rotating, and scaling.
Right.
And it even gives examples of how scripting can be used to create patterns and grids. It's like a peek under the hood of how some of this algorithmic design actually works. Think of scripting as giving you the power to write your own like specific rules for design.
Right.
For example, like instead of manually adjusting the spacing between hundreds of columns,
Right.
you could write a simple script to automatically space them based on mathematical ratios or environmental data.
Right.
It unlocks a new level of customization and control.
Exactly. Yeah. I mean, Chapter 4, I think, provides a foundational understanding of how designers can begin to engage directly with the computational logic that underlies algorithmic design.
Right.
By introducing the basic building blocks of scripting, it empowers designers to move beyond the preset functions of standard CAD software,
Yeah.
and start creating their own custom tools and processes.
Okay, so following that, the book explains Boolean operations in algorithmic design, showing how scripting can be used to combine or subtract simple geometric shapes to create much more complex forms.
Right.
This is a really like fundamental concept in digital modeling.
Yeah.
And it's powerful to see how algorithms can like automate and extend these basic operations.
Yeah, this demonstrates, I think, a core computational approach to generating complex geometry.
Right.
Boolean operations provide a really precise and logical way to construct intricate forms by combining, subtracting, or intersecting simpler primitives.
Right.
And scripting allows for the automation and customization of these operations.
Yeah.
Enabling the creation of highly detailed and parametrically controlled designs.
Okay, then there's the idea.